Have you ever hopped on a scooter, twisted the throttle and just gone? That feeling of instant movement, the wind in your hair, and the city blurring past you? It's almost like stepping into the future. There's no hesitation, no fumbling with levers or worrying about stalling. Just a simple twist, and you're off, gliding effortlessly through the streets. No clutch, no gears, just smooth, uninterrupted motion. It's a sensation that's both liberating and a little mysterious, especially if you're used to the clunky gear changes of traditional motorcycles or cars. It feels like magic, but it's really clever engineering at work beneath your feet. There's a whole world of innovation packed into that compact frame. Most riders just enjoy the ride, never giving a second thought to what's happening under the body panels. But if you're curious, let's peek behind the curtain and discover what makes this effortless experience possible. How does a scooter shift without gears? How does it manage to accelerate so smoothly, without any jerks or pauses? That's what we'll uncover today. We're diving into the heart of the modern scooter to reveal the secret behind that effortless acceleration, the technology that makes your daily commute feel like a breeze. The answer lies in a marvel of modern mechanics: the continuously variable transmission, or CVT for short. Don't let the name intimidate you. The concept is actually quite simple once you see it in action. The CVT is designed to automatically adjust to your speed and power needs, so you never have to think about shifting. Unlike traditional motorcycles or cars with fixed gears, a CVT offers an infinite range of gear ratios. This means the engine can always run at its most efficient speed, while the transmission seamlessly adapts to your acceleration. Instead of shifting, it flows seamlessly, giving you that buttery smooth ride every time you twist the throttle. There's no lag, no clunk, just pure, continuous motion. So, let's pop the side cover off, at least in our minds, and explore this ingenious system together. We'll see how all the parts work in harmony to deliver that signature scooter experience. We'll break down the pulleys, the belt, and the clutch that keeps your scooter from stalling at a red light. Each component plays a crucial role in making your ride as easy and enjoyable as possible. By the end, you'll appreciate your twist-and-go ride even more, and understand the mechanics that make it possible. You'll see why scooters are the go-to choice for city commuters and anyone who loves a hassle-free journey. It's the kind of engineering that makes scooters so fun and easy to ride. The simplicity on the surface hides a world of smart design underneath. Ready to see what's inside? Let's get into it and unlock the secrets of the twist-and-go ride. Scene transition. So, what is a CVT? Let's break it down and see why it's such a game changer in the world of scooters and small vehicles. Traditional transmissions use metal gears. Big ones for power, small ones for speed. Each gear is a fixed size, and you have to switch between them as you ride. To change ratios, you shift gears, feeling that familiar clunk or jolt as the teeth mesh together. It's mechanical, direct, and you can feel every change. A CVT, or continuously variable transmission, does the same job, changing the ratio between engine and wheel speed, but with no traditional gears at all. It's a completely different approach. Instead, it uses a clever system of pulleys and a V-shaped belt. This setup allows for infinite variability between the highest and lowest ratios. Imagine two cones facing each other, forming a groove for the belt. As the cones move closer or farther apart, the belt rides at different heights. There's a matching set on a second axle, connected by the same belt. Both sets work together in perfect harmony. The magic is that these pulleys can change their width, making the belt ride higher or lower. This is how the CVT smoothly adjusts the ratio. By adjusting both pulleys at once, the CVT creates a seamless range of gear ratios. There are no steps, no pauses, just a continuous flow. It's like a dimmer switch for your power. No steps, just smooth transitions. You get exactly the right amount of power for any situation instantly. The engine stays in its sweet spot, delivering optimal power and efficiency, while the CVT handles all the adjustments in the background. The result? Smoother, smarter acceleration. Whether you're starting from a stop or cruising at speed, the ride feels effortless and refined. No clunks, no jerks, just pure linear motion. It's a more comfortable and enjoyable experience for both new and experienced riders. That's the genius of the CVT. It's a simple idea, executed with precision, that transforms the way your scooter feels on the road. Scene transition. Let's take a closer look at the main players inside a scooter's CVT, or continuously variable transmission. This clever system is what makes riding a scooter so smooth and effortless, allowing you to simply twist the throttle and go, without worrying about shifting gears. First up is the primary pulley, also known as the variator. This part is directly connected to the engine's crankshaft. As the engine spins faster, the variator automatically adjusts its position, starting the process of changing the gear ratio. It's a smart mechanism that responds instantly to your throttle input, making acceleration seamless. Next, we have the secondary pulley, or driven pulley. This component is linked to the rear wheel and receives power from the primary pulley through the belt. As the variator changes its size, the driven pulley adjusts in response, ensuring the right amount of power is delivered to the wheel at all times. The V-belt is the unsung hero of the CVT. Made from tough, flexible materials, it grips the angled sides of both pulleys, smoothly transferring power from the engine to the wheel. Its flexibility allows it to move up and down the pulleys, constantly changing the effective gear ratio for optimal performance. Finally, there's the centrifugal clutch, which is usually located inside or just behind the secondary pulley. This clutch uses centrifugal force to engage and disengage automatically, depending on engine speed. When the scooter is idling, the clutch remains disengaged. This means the engine can run quietly without turning the rear wheel, so your scooter stays still until you're ready to move. As soon as you twist the throttle and increase the engine speed, the centrifugal clutch springs into action. It automatically engages, connecting the engine's power to the rear wheel and propelling the scooter forward with no extra effort from you. These four essential parts, the primary pulley or variator, the secondary or driven pulley, the V-belt, and the centrifugal clutch, work together as the heart of every gearless scooter. Each one plays a crucial role in delivering that smooth, automatic ride. When combined, they create a system that's simple, effective, and incredibly reliable. That's the magic behind the CVT, a perfectly synchronized dance of parts, giving you that signature twist-and-go experience every time you ride. Scene transition. Now let's zoom in on the variator, the brains of the operation. Inside, it hides roller weights that move within curved ramps. At idle, these rollers sit near the center, waiting for action. As you twist the throttle, the engine spins faster, and centrifugal force pushes the rollers outward. The rollers slide up their ramps, pushing the movable pulley half inward. This squeezes the belt, making it ride higher in the groove and increasing the pulley's effective diameter. The result, automatic, smooth gear changes based on engine speed. No electronics needed, just pure mechanics. Low speed keeps the rollers in for takeoff power. High speed pushes them out for cruising. The variator and its rollers are the simple, elegant engine of change in the CVT. Scene transition. While the primary pulley changes size with engine speed, the secondary pulley balances things out. It uses a strong torque spring to keep the belt tight and maintain smooth ratio changes. At idle, the secondary pulley is large, giving you low gear for takeoff. As you accelerate, the primary pulley grows, the belt pulls, and the secondary pulley shrinks. The V-belt must be strong and flexible, gripping the angled pulley sides for maximum efficiency. This constant tension and balance is what makes the CVT work so smoothly. Scene transition. Let's see the whole system in action, from a stop to cruising speed. At a red light, the variator's rollers are centered, the primary pulley is small, and the secondary pulley is large. The V-belt runs like a steep hill from front to back, your first gear. The centrifugal clutch is disengaged, so the wheel doesn't move. Light turns green, you twist the throttle. The clutch engages, rollers move out, the primary pulley grows, and the belt rides higher. The secondary pulley shrinks as the belt pulls it down. The gear ratio changes smoothly, giving you seamless acceleration. At cruising speed, everything balances out for efficient motion. Need more power? Twist the throttle, and the system instantly adjusts. No shifts, no jerks, just a constant, responsive ride. That's the dance of the pulleys. Scene transition. The centrifugal clutch is the unsung hero of your scooter. It keeps the engine running at a stop and connects power to the wheel when you accelerate. At idle, clutch shoes are held in by springs, so nothing moves. Twist the throttle, and centrifugal force flings the shoes outward to engage the clutch bell. The more you rev, the stronger the connection. Slow down, and the springs pull the shoes back in, disconnecting the wheel. Simple, automatic, and effective. Scene transition. So what's the payoff for all this clever engineering? The biggest advantage, smooth automatic acceleration. No shift points, no lurching. In city traffic, you just focus on the road and throttle. The CVT does the rest. The engine stays efficient, often improving fuel economy and reducing emissions. Fewer jolts mean less wear and tear, boosting reliability and longevity. The compact, lightweight design keeps the scooter nimble and easy to handle. For new riders, no clutch or gear shifter means a gentler learning curve. Just twist and go. That's why CVTs rule the scooter world. Smooth, efficient, reliable, and easy. Scene transition. 12. Let's take one last look at the CVT in action, a true mechanical symphony. Your wrist twists the throttle, the variator's rollers move, pulleys change size, and the V-belt transmits power. The centrifugal clutch engages, sending motion to the rear wheel. Every part works in harmony for seamless acceleration and smooth stops. From the outside, it's just a twist of the wrist. Inside, it's a beautifully choreographed dance of physics and mechanics. The CVT turns engine power into effortless motion. Next time you ride, remember, it's not magic, it's engineering at its finest. And for those who love to know how things work, that makes every ride even sweeter. End.